depends in depth and some of the security architecture of our platform. Okay, so quickly to establish some context before we get into the technicalities. We are primarily a Java shop. Most of our applications, most of our services, including some of our internal tools, are built in Java. Most of the engineers that we have are good with Java, but we have been. Nikhil, can you please go back? But we have started to adopt Go as well as one of the tech stacks here at Chargebee. And on the security side, we do have a dedicated security team, which is responsible for vulnerability management, security testing, responding to vulnerabilities, and generally ensuring that the overall Chargebee application and infrastructure is secure as well. What we are going to talk about is more on the security automation side of things, specifically on the application security side. We are not going to go on the infrastructure or the internal security or the IT security side of things. Just like I think most other SaaS companies, we are also we have multiple releases in a day. We have a pretty good engineering velocity. We release multiple times a day. We have multiple services which gets released during the day. One of the good things here that has kind of helped us on the security side is that during the early days, our the initial architects and the initial engineers, they have always considered security to be important. They have looked at things from a least privilege perspectives, right? So most of our applications, most of our infrastructure, we have a lot of least privilege and security. I would not say a lot of security controls, but generally we have followed this principle of least privilege in most of the engineering decision that we have taken. And we have also considered security as part of our application framework since quite early days of Chargebee as well, which has actually helped us a lot. Hey, sorry, one thing I forgot to check. Am I audible properly?
Yes, Abhishek, you are.
Yeah. Okay, great. So, okay. So I'm assuming that since most of you who have joined this call, you're interested in application security, and I'm also assuming that most of you maybe already be familiar with application security to a certain extent, but we'll quickly, in a fun way, introduce what is application security. I'll probably take a pause and let you all to go through this XKCD cartoon. I think now these are called memes probably. I don't know. No, maybe not. Okay. Whatever. Just go through this. I'm not going to explain this context here. Okay. Anyone found this funny?
Yeah, this is very, very infamous.
Yeah. This is like a classic example, right?
Yeah.
So I won't get into a definition of application security. I will just say that application security is just to ensure this does not happen, right? So we have to do whatever is required so that this kind of this and other kind of issues like this is generally avoided as much as possible. Nikhil, can you go to the next one? Yeah. Okay. Now, we spoke about what is application security. Now, what happens if your application is not secure? Why should you care? Especially for early stage startups, right? You have to move very fast. You have to roll out features. You have to understand what your customers are looking for and quickly roll out. And why this security? Why additional overhead of security, right? The fundamental reason is just like your quality, availability, and other NFRs, security is also one of the non-functional requirements that we all consider, right? And it's not just for the sake of it. It's actually very important. So if you see this infographic, you will see that in last couple of years, large organizations have faced data breaches some of which has resulted because of application security issues, and some of which has resulted due to maybe infrastructure security issue. But in all the cases, eventually it has led to massive data breaches, customer information, payment information, or other business sensitive information has been leaked, right? I'm not sure if you are aware, but recently Okta was compromised, and people posted very scary images of attackers being able to access different Okta tenants. While it is not completely known, but if if you use Okta or Okta-like technologies, SSO technologies, right? Then imagine if that is compromised, then attacker may access, all your applications which do not have an additional uh, factor of authentication. I think there is some disturbance. If can you everyone go into mute, please? But feel free to unmute and ask a question if required. Thanks. Okay, so generally being secure is really not a choice if you're operating a business, because being secure will allow you to gain customer trust and allow you to increase your business, acquire more customers, and vice versa. If you are not secure, if you are breached, then it will affect customer trust and may lead to customer loss, right? So generally, just like your other quality metrics, security is as important as other quality metrics, right? Now, I'm not sure how many of you are aware of OWASP project. Anyone here who is not aware of OWASP project? Anyone? Please feel free to just raise a hand or maybe drop a note in chats. Okay, awesome, great. Okay, so I'll spend 2 minutes on this slide. The OWASP project is probably the best source of application security knowledge, guidance, tools, methodologies, basically everything that you need in order to build and run an application security program available to you free of charge, because it is a community run initiative, mostly community run initiatives, right? If you are not familiar with it, or even if you are familiar with it, please be familiar with the various OWASP projects, especially the ones which we find to be particularly useful. Things like OWASP ASVS, OWASP SAM, OWASP Proactive Security Controls. There are a bunch of great OWASP sub-projects which allows you to really learn what is application security and build a fairly complete application security program for your organization based on the OWASP tools and methodologies, right? So feel free to, I would definitely encourage to check out the OWASP projects. Okay, now before we get into what we call continuous application security or how we do it, let me just quickly talk about our opinion of what is the minimum application security capabilities that anyone who is getting started, especially for product teams, organizations which are building their own applications, microservices, deployable components, and all of that. What is the minimum capability that you should have, right? So from our perspective, I think these are some of the minimum capability that you should develop. And we will talk about how we actually achieved each of this using mostly open source tools, right? But it's not about just running these tools, right? It's about making sense and making value out of these tools. Because if you're looking at from an engineering perspective, if you're looking from a product organization perspective, right? Just by knowing about problems in your application is not enough, right? You have to drive towards a place where these problems are remediated on a continuous basis, right? So maybe we'll talk about briefly on what are our goals, how we are thinking about this continuous security. But along with ability to continuously detect application security problem, it is very important for you to align your organization to be able to continuously fix or remediate these problems as well, right? Only then, as an organization, the security maturity will improve, right? So we'll see how these, what are the details of each of this type of application security capabilities that you should have, and what are the tools that you can quickly adopt to have something. Okay, yeah, Nikhil, please move to the next slide. Okay, now why continuous security? Traditionally, I mean, application security is not new. It has been there for like multiple decades now, right? The traditional approach would be after your feature is developed, the functional and maybe probably hopefully non-functional testing are done, then you go for a security testing, right? Probably someone from internal or outside the organization will do a security testing on your application, and then finally will certify, yes, this application is secure, you can go ahead and deploy to production, right? But imagine now, especially in SaaS organizations, imagine the number of deployments that you are making in a day, right? Or maybe not in a day, in a week. The engineering velocity has generally increased. We don't want to wait for very large release cycle or very long release cycle. We don't want a large feature to be built and then tested over iterative multiple times before it is released. We want to make incremental small changes and continuously release. But the important part is that it is changing. You are making a change, and that change needs to be tested and needs to be verified for security as well. Just as we as the CI/CD culture has significantly matured, right? CI/CD, or with having good quality unit tests, integration tests, component tests, allows us to release with confidence, allows us to continuously release with confidence, right? Similarly, such continuous security capability is also required to release with confidence. Every change which has a potential of breaking a feature or introducing a problem, introducing a regression, has the potential to introduce a security vulnerability as well, right? So it's not just your unit tests and integration tests, you need the ability to test for security issues as well. And that is where we come from when we say we want security or continuous security as part of the continuous delivery as well, right? And also, if you look at generally security and engineering teams are disproportionately scaled, right? You will never have one-to-one mapping of developers and security engineers. You will generally have a very, very small security team compared to the large engineering team. Correct me if I'm wrong. If anyone has a very large security team and have a very good developer to security engineer ratio, please raise your hand. I would really love to know about it. But in my experience, generally the ratio is skewed, right? So in that way, security teams will become bottleneck if they have to do a manual testing every time a change is made. It's just practically not possible. So that is the reason we have to think in terms of continuous security, right? And maybe the security teams can focus on manual testing only for very, very high value feature or changes that are made in very, very security sensitive components, like maybe say authentication authorization or something to do with a critical security sensitive component like say credit card vaults or secrets managers and all of that, right? Yeah, Nikhil, please move to the next slide. I think we already answered this. I mean, I hope there is a general agreement that manual security testing cannot scale in a high engineering velocity environment, right? So just like on the dev side of things, right? We have started writing test cases. We have this test-driven development, right? We write test cases or the behavioral specs even before the first line of code is written. Well, it's good to have. I'm not sure how many of your organization is actually following TDD to a large extent. It's a great thing, but we have started doing that as an industry. Similarly, the security organization is also shifting left, right? Security team cannot come towards the end. Security has to start very early. Good and matured organization would probably start with very high, from the architecture level, doing a security architecture review, threat modeling. Then most of the common security gates are in place, automated, and then manual testing for critical components. That's how I would probably see a fairly matured security organization, right? Okay, now comes the meat of this presentation, right? What is our opinion of building whatever I just spoke about, right? So we have some context. I'll share the why part of it, but I'll also talk about that this is a new initiative for us. We have been doing this for some time. Many of the things are already done, and we are started to see some result, but we still have a lot of long way to go, especially on the cultural aspects of it. If you think about DevSecOps, I see some people who I personally know, and I know they work on DevSecOps side of things, right? If you really think of DevSecOps, it's as much a technical shift as much as it is a cultural shift. Because of the skewed nature of the dev to security engineer ratio, it is just not possible for security engineers to drive security initiatives all by themselves. You need to make it decentralized. You need to ensure that your organization as a whole understands the security problem, and security becomes a shared responsibility, right? You need to make security technologies self-service. You need to establish best practices so that most people in the organization are aware of security impact or security consequences while making a decision, right? That is our goal as well. We don't want to become a bottleneck in engineering. We don't want to build, or enforce our opinion on everyone else. We want to build that alignment that everyone thinks shipping out secure software is cool. Everyone becomes proud of shipping secure software, right? So that is where we want to go. We have achieved some aspects on the technical side of things, but a lot of on the other things are left as well. But generally, for the continuous security initiative, the idea is that we want a technology-driven way to provide centralized visibility of the security posture of different services, different deployable components like libraries, microservices, and all of that in a centralized location. The objective is to drive self-service. We would want to show the developers and the individual service teams that this is how your security looks like. So take action. If you need help, reach out to the security team, but take action, right? This is the first step. The first step of building security awareness and providing the necessary security visibility. But as you will see, most of our security tooling components, the tools, the scanners that we have built, they are built as reusable component. These components are used by us to provide the centralized security visibility and can be adopted by individual teams as part of their CI/CD pipeline to build security gates, right? The moment I talk about security gate, it's something very nice for the security team, but many times it's quite painful for developers or engineers, right? You don't want to be get blocked for everything. You want to get blocked for only for very, very critical issues or issues which are proved to be there, right? So that transition we want to happen at a cultural level or at a organic level, that starting from centralized visibility, taking action, then adopting this as part of the CI/CD and creating some security gates for at least for critical critical components of the overall the ecosystem. That is what we want to do. And generally, we have a internal goal. We want to find vulnerabilities before others do, right? But we know that this goal cannot be fulfilled always. In fact, there will always be vulnerabilities. But we want to adopt a system. We want to adopt a practice that every time someone finds a vulnerability, it improves our program. It improves our technological capability to find similar vulnerabilities automatically in future. Okay, let's go deep into the technical side. Nikhil, feel free to take over.
Yeah, thanks, Abhishek. Hi, everyone. So from this slide, we will talk about the overall architecture of how our AppSec pipeline looks like. So on your screen, you can see it starts with a nightly scan trigger, and you what it means is most of our production touching repositories will be scanned on a nightly basis at a scheduled time. So the entire CI pipeline is based on GitHub Actions. GitHub Actions provide us a couple of different features that we can use to, build and scale a larger AppSec pipeline where we can onboard larger number of repositories. We can subsequently handle each and every part of the CI pipeline very, very, very useful in a very useful way. One of the main advantage that I would like to mention here is something called as GitHub reusable workflows. So the concept of GitHub reusable workflows was very helpful for us because it helps us to build and scale the pipeline. So we don't have to do the repeatable task again and again. So you can think of in a way that you wrote a program, and then whatever you feed to that program process it like the typical input output based program, right? So that's probably how the baseline for this entire CI pipeline based on. You can provide some inputs. Basically, it has got some sort of default inputs and default configurations, so you don't have to manually edit every time until unless there's a different requirement. So the one of the main advantage of using this sort of architecture is, let's say down the line or in the next month you have a different requirements, and then you want to adopt a new capabilities or you want to place a new features, maybe some new rules. So now one change at one place can easily make available in all the repositories or all these scans which usually happens at an nightly scan. So this helps us building and scaling our CI pipeline. So when I say the application security pipeline, it goes through mainly the four phases. The first one we have is the SAST, which is known as static application security testing. The second one is SCA, also known as software composition analysis, and then secret scanning, and followed by the SBOM generator. Now, these four technologies, including with DAST, also known as dynamic application security testing, we will talk about them right after this slide. But yeah, in reference to this architecture, you can see all these four tools or capabilities are containerized custom solutions, which means we have our own customized solution on top of some open source tools or on top of some technologies that could be used by individual engineering teams uh, at the organizations, or we can also use it, and maybe the security team can use it, maybe the devs can use it, and basically it's open for everyone to adopt. Now all these containers are dockerized and put into AWS ECR, and then so that whenever there's a workflow run at a nightly basis, we can pull those containers easily, and then we can run our workflow. So once the application, or I would say the repositories goes through each of these phases, and we have the result. The results are uploaded as a GitHub artifact, which means you can see the scan results in the GitHub directly, which is available for quite a few times. And then we archive those results into a S3 bucket, so that we know so that we can track basically the number of bugs over the time. We can see the dependencies and all those things. And then what we do is once there's an action in S3 bucket, we have a Lambda function that triggers and it sends all the results, which is the outcome of these tools, to a Jira and maybe a ELK based solution to solve the visualization problem. And that's where you can monitor how healthy is your application is. You can see the number of vulnerabilities that you have. You can see the number of third-party dependencies you have. You can see the number of software components that you use or third-party libraries that you use. And all of those things are visible at a centralized place. So that's how it looks like. And then once the results are sent to Jira and maybe the ELK, then also our security team can interact with the Jira and see if there is any critical finding that is being resulted on for this scan. And maybe there are other findings as well. So security team can always interact with the board and can see and take action accordingly. So next, let's talk about the SAST capability and basically the importance of SAST. So static application security testing is something that detects the vulnerability in application source code, which means you don't have to actually host the application. You can integrate the SAST as soon as you start writing the code, and then once you integrate this in the CI/CD pipeline, you can make sure that automatically it will review all the changes for any insecure configurations or insecure coding practices or etc. So to achieve this capability, we use something called as SemGrep. So SemGrep is an open source static application security testing tool which supports large number of community-driven security rules for various different languages. Primarily, it supports Java, it supports Spring Boot, it supports Python, Go, and TypeScript, JavaScript, and all those languages are supported by SemGrep. Another important feature of SemGrep that I would like to quote is it supports writing custom rules and custom code detections. And what does that mean is, so mostly if you have let's say if you have any customized framework in your organization based on any technology, maybe Java or something like that, then you would want the SAST capability to identify those custom patterns as per your need, which is not the case for everyone, but that's specific to you. So all those cases are all those cases, and to detection of all those cases are pretty much very helpful with the SemGrep. So you can see a simple screenshot of the custom solution, and what it does is it is scanning basically the Java source code. That's where you provide the profile equals to Java and then your target path. So the primary reason for developing this sort of custom solution is to drive adoption. Obviously, that's the one thing. Another thing is we want to build this tool on top of our expertise. We don't want the developers to go and look for different packages, different rules, different custom rules to detect any of the vulnerabilities. We want the user to use a very simple interface, and then rest of the things the tool will take care of, so that it will find the right profile, it will find the right rule, and it will we can write the custom rules that could be attached to any specific profile, and then the devs can see the results, and that will basically detect a lot of vulnerabilities. Another main advantage of SAST is it takes some time to mature it. What I mean is, and also the another capability is we want to stop the recurring bugs that usually happens within the organization. For instance, let's say if you have any vulnerabilities flagged by any sources, could be from the external team, could be from bug bounties, could be from your security team, Now we want to use the SAST capability to detect all such other patterns. So we make sure that these kind of things will never occur again, or the same pattern at least would not occur again. So with the same way, we can write a custom rule, and then we can support any specific vulnerability, and then that could be detected the next time somebody wrote the same code, or maybe in the existing pipeline, existing code. Yeah, moving to the next slide. Sorry. Yeah, so the next we have is dynamic application security testing. So unlike this SAST, the dynamic application security testing, or DAST, it detects the vulnerabilities in a deployed environment. So it gives you capability to find sort of configuration related issues. It interacts with the application as an external attacker. So that it will give you the results that how external attacker can communicate with your website, how it can find the vulnerabilities, and also how it can test the authenticated and protected endpoints of your application. So for DAST, there are a couple of tools, and one of the good open source tool is OWASP. And we also use a commercial solution from Qualys, the Qualys BAS. The next phase is the software composition analysis, also known as SCA. So what SCA does is it detects vulnerabilities in open source libraries, and what it means is so there's a very famous saying that generally we write less than 20% of code deployed component are written in house, which means we build on top of any open source libraries, we build on top of any third party libraries, and greater than 80% code comes from the open source libraries. That inherits the risk in our application. And if I recall, there's a very recent incident of Log4j, right? A lot of companies were using Log4j to log different activities. They built sort of frameworks on top of Log4j. So you can assume if a library is used by so many people around the world, and one day some and one day some vulnerabilities has been detected in Log4j, so maybe that could break the entire internet. So to find such vulnerabilities, to find such issues in the components that you are using, you use something called as software composition analysis. So you are aware that whatever the third-party components or open source libraries I'm using, they might be vulnerable. They might have some vulnerabilities, and to detect all those problems, you can use the SCA. For SCA, we use OWASP dependency check, and I think it works very fine. Okay, now I think the another problem is the secret scanning. So a lot of modern softwares these days.
Nikhil, if you don't mind, there are a few questions that have come up. Maybe we can take a couple of them and then sort of proceed.
Sure. Okay.
Yeah, where are the questions? I was looking at
Even I can't see it.
Yeah, so in the bottom right, there's a triangle, circle,
Right
square.
next.
Okay. Bottom
Click on
right
that and the
triangle.
Q&A. Yeah.
Q&A. Okay.
Oh, I think we have a couple of questions.
Yeah.
How do you scale custom rule writing for hundreds of applications? This I just replied in chat. Maybe we can also discuss about it towards the end. SameGraph on pre-commit hook is usually slow. So see, SameGraph is actually one of the fastest SaaS tools that we have seen. If you use other commercial SaaS tools like say Fortify, or even the newer ones like GitHub's CodeQL, it is much more slow actually, because those tools take a different approach, which requires whole program analysis. Like in case of GitHub's CodeQL operates on a intermediate representation of your entire application. So it needs to build your application with its own instrumentation injected, so that it can execute queries on top of your application. So SameGrep, I think we found to be one of the fastest one available. We have so far not, I mean, whatever time it takes, we consider it to be acceptable. When you find issues by SCA in a third-party component, do you insist your developers on? Okay. So regarding the question from topic, this is one of the biggest problem. If you build a policy to always fix third-party vulnerabilities, you only have to fix third-party vulnerabilities. We cannot work on any features, right? This because if your application is fairly large and you have exposure to a lot of third-party vulnerabilities, every day we will obviously see some vulnerabilities. The way we think about it, at least, is that we would want to fix the critical vulnerability at least. We try to increase our test case coverage as much as possible so that upgrading libraries, at least in the same major version, should not have much manual intervention to it. Like if you upgrade the library and the test cases are passing, then we are generally good to go. But obviously that is a dream state to have. There are a lot of complications to it. But yeah, I think I don't think we consider that every single library vulnerabilities have to be fixed. We insist that you upgrade the libraries for at least for the critical vulnerabilities. And also as a policy, we encourage developers to use libraries which are maintained. Don't use libraries just from some random sources which are not maintained. Does that answer your question, topic? Okay. Regarding depend about versus SCA. Okay. Both depend about also does a level of software composition analysis only. It also finds third-party vulnerabilities. But in our solution, at least the way we have built or integrated OWASP dependency check, we have implemented it as a plugin, a Gradle plugin, or as a Maven plugin in our Java build tooling ecosystem. This view of integrating within a package manager allows dependency check to see not just the immediate dependencies, but all the transitive dependencies as well, right? You declare 10 libraries in your application. Those libraries transitively depends on a lot more libraries, right? If you just run Gradle dependencies, you will see so many libraries there, right? So I am not sure if GitHub's Dependabot does transitive dependency analysis nicely, how nicely it do, or how does it do transitive dependency analysis, because there are some challenges in that. But we felt that dependency check, when adopted in the right way, can do a pretty good job because of the nature of the problem. Secondly, dependency check, or at least GitHub's Dependabot, at least, I mean, last time when we checked, it used to be more of a passive detection. Like it will continuously scan your repositories and maybe raise those alerts or raise pull requests that there are some vulnerabilities. We wanted to build SCA as a capability which can be used to scan and as well as use within the CI pipeline to fail the build with certain policies. So in our case, this wrapper on top of dependency check allows us to fail the build if there is a vulnerability detected with CVSS score, say, greater than 7 or so. So we figured that we need a tool which can be deployed inline in the CI/CD cycle, or CI/CD pipeline, and not just as a package scanner. Does that answer your question?
Yes, it does. Thanks, Abhishek. Yeah, thanks for the detailed answer.
Thanks. Should we go ahead?
Yeah, I think so. Okay. Yeah, so the next part was the secret scanning. And with the modern software, I think it's it's very, very common to integrate with other third-party services, or maybe the services that maybe the same services. Services belongs to the same within the organization as well. A clear example, as I mentioned in our AppSec pipeline, is that we use GitHub. We use the GitHub, the data which is produced by the scan, and that gets uploaded to GitHub as an artifact, and then send it to the AWS in the S3 bucket. So that's again a good example of the third-party integration, right? So you need to authenticate your GitHub with AWS. So, and these are the common problems. Let's say you want to integrate something with Jira. So what you do is you create a API token. You maybe hard code that token into the code, maybe into the configs, and then that's how you use it. So there's been a couple of incidents in the past where this was a problem for even some of the bigger organizations. So what they have done, they accidentally post some of the AWS secrets into their GitHub repo, and that got public over the time. And then people see it, and then there was a breach because of these issues. So similar to this example, like in our AppSec pipeline, we don't use secrets to authenticate GitHub to AWS. We use something called as OIDC, also known as GitHub OpenID Connect. So that's again a very good feature from GitHub that provides you to follow the least privilege access on a specific branch, on a specific repo. So you don't have to deal with the secrets. You can just create some roles and then define some roles in AWS. You can define the boundaries. You can always follow the least privilege access, which is required, and sort of these things. So to achieve or to achieve the secret scanning capability, we use something called as Git leaks. So Git leaks supports for most of the common secret pattern detection. And on top of it, it also supports the custom pattern detection as well. For instance, you might have some third-party API services, or maybe within organizations, you have to communicate with other services that requires the custom token to be present, and that may not be supported by the Git leaks by default. So what it does is you can write a custom pattern to support all those things as well. So once you integrate in your CI or and the AppSec pipeline, you will be able to understand if the developers accidentally post any of the secrets, maybe in the code or maybe in the GitHub commit history, and basically, yeah. So you will get to know if there's been any secrets which has been detected by the Git leak. So here is this simple screenshot. You can see we are running the Git leaks in a detect mode, and then if it finds a vulnerability, it gives the warning that it finds one leaks, and if not, it will just say that no leaks found. So which means you are good to go. So the next thing is, I think this has been pretty popular because of the recent incident. That is, I would say, the series of incidents which is coming from like the recent Log4j, then Spring4 shell, and all these incidents made happen. All these incidents basically gives the probability for the SBOM. So SBOM is software bill of materials, which means it detects all the direct and transitive dependencies and their open source licensing information from package manager configurations. What does that mean is, so maybe you are using any of the libraries, any of the open source libraries, and that open source libraries further is dependent on some, maybe let's say 10 other libraries, and those 10 libraries will be depends on other libraries. So with SBOM, you can have the entire inventory for all those things that is depends that you are using for any particular component, and you can also get the licensing information. So most of the organizations, they have the legal boundaries, they have the legal problems, and GDPR problem is there that you cannot use these licenses, you can use these licenses only. So all of these problems can be solved once you have a good database of your software bill of materials. So you know what we use and how to deal with it. And it also helps you to quickly respond to all such incidents such as Log4j, Spring for Shell, and all these vulnerabilities. So to achieve the SBOM capability, we again have the custom solution on top of Cyclone DX. So there is one more solution, SPDX, but the Cyclone DX is sort of standard, and it supports the standard JSON format, which is basically the Cyclone DX standard. So here's a quick snapshot where you can see it says we use this dependencies and what are the licenses that it uses. So you can see it uses Apache 2.0, and then all of those things will be available once you have the SBOM or software bill of materials generated from the tool. So the outcome, let's talk about the outcome. So as Abhishek has mentioned a couple of things at early start of the presentation, like where we are, what we have achieved, and we are still working on a few things. So these are the few outcomes which we achieved as of now. The first and usual one is the identification of multiple high-risk security issues. So this is something very good. I mean, we were able to detect a couple of high-risk vulnerabilities as a result from our AppSec pipeline. Now, and also we have achieved these nightly scanning capabilities for most of our production touching components. The another advantage is we have also now visibility of our third-party risks and software bill of materials for almost all the production touching components. And basically, you have the overall security posture view of different application within the organization. So you know which application is healthy, which is not, which is producing so many bugs, so many third-party dependency issues, so many maybe the licensing issue or something like that. And also, as I mentioned when I was talking about the SAST, like using SAST and then avoid recurring security issues was one of our biggest achievement that a SAST could achieve, in my opinion. So, for instance, whenever we have any vulnerabilities which has been detected, maybe from the external vendor and internally, so you can again write the custom rules and then make sure that it would never, the same pattern at least would never occur again in the same code or maybe within the organization. And the last point is towards the culture of self-service and automated security. I think this is also Abhishek mentioned that we don't want to be the bottleneck for the process. We want to develop the security capabilities so people use it. They get excited to deploy the secure software. We don't want to throw security to anyone. Yeah, I think let's move to the next slide. Abhishek?
Yeah, thanks, Nikhil. I think we are kind of, crossed our time, so I will not take a long time on this slide and probably open up for questions so that we can have some interactive discussion. But just wanted to, acknowledge that if you are into the defense side of things, that means if you're responsible for protecting your application, your job is actually incredibly difficult. If you think about it, you have so many components, so many services, so many things in your infrastructure, and mostly attackers would need to find one flaw involving so many different services, right? However, from a defender's perspective, you need to be generally aware of everything that you have. You need to be aware of all the different types of risks, and you need to proactively remediate them, which is incredibly difficult actually if you think about it. Now, from a security engineering perspective, at least my experience is that response vulnerabilities just doesn't work, right? We need a baseline capability to find common security flaws and fixing them. but eventually it becomes a cat and mouse game. You will end up having like continuous vulnerabilities reported to you, and you have to dedicate say 20 or maybe 30% of your team's bandwidth just for fixing security issues, which eventually over a period of time becomes really complex or really expensive, I would say, right? So if you really think of security as an engineering problem, I would say that, think of proactive security. Think how you can eliminate class of vulnerabilities, right? If you study operating system security, it has matured incredibly in last 2 decades. It was practically possible to find vulnerabilities in Linux kernel or even important services just by using Gray, right? And now, obviously, such vulnerabilities are not there. But even if you find vulnerabilities in applications running over Linux or say OS X or even Windows, exploiting them is very difficult because operating systems are trying to mitigate class of vulnerabilities. Similarly, when we are thinking of application security, we have to see, instead of fixing one SQL injection or one cross-site scripting, how can we ensure that there is no SQL injection in any of the applications in my infra? How can we adopt, say, a ORM layer or build a layer between data and code, which takes care of, which ensures appropriate segregation of code and data to prevent SQL injection. Similarly, instead of fixing cross-site scripting continuously, we have to see how we can implement, say, content security policy to harden our front-end application. So even if there are possibility of code injection in the front end, that CSP mitigates some of the risks out there, right? Yeah, and finally, the last point is, as I kind of stressed when we during the early part of the presentation, that security is everyone's responsibility. Don't think that security is only security team's responsibility. In that case, we will make the security team a bottleneck, right? See how we can enable engineers, especially the people who are working on engineering problems, writing code, so that they are more aware of security and they have all the tools and information necessary to remediate security issues or make better security decisions, right? Yeah, that's about it. I think we can go to the last questions. So yeah, feel free to ask any questions that you may have.
Yeah, this time, just unmute yourselves and ask questions rather than typing them.
I think that would be better.
Yeah. Okay, I don't think there is any questions, so probably we can close. Thank you, everyone.
Thanks, Abhisek. Thanks, Nikhil. Thanks,
a lot.
everyone.
Thanks, everyone.
Bye.
Bye.
Thank you, guys.
Thank you.